Okay, I believe these ones are causing a bit of hassle, so we'll get started on this. Okay, so I'm just going to grab a protractor here. So let's drag this down a little bit. First thing I'll do is north 20 degrees east. So see the way north is the first letter? You go all the way up north, like so. Oop. Let's hope I can still... No, I can't access it anymore. We'll try this again. Okay, so the first thing I'll do is make sure that this is dead straight, which it should be. Okay, so you go north 20 degrees east. Sorry, my fault. So north 20 degrees west. Okay, sorry, north 20 degrees east. So you go all the way up north, and then you go 20 degrees, which is two of these lines, to 70, and there you go, that's north 20 degrees east. Next thing you're going to do is south 60 degrees west. So you go south, like so, and you grab a line, and you go 60 degrees west. So you start off with south, and then you go up 60 degrees, so you're at 90, you see 90 there, and you should end up around 30. So that's south 60 degrees west. Next one, south 50 degrees east. So go south again, and then just go 50 degrees to the right. 1, that's 20, that's 30, that's 40, and that's 50 degrees to the right. And finally north 70 degrees west, which will be, start with north, and then go 70 degrees west, which will be all the way down to there. Okay, and there you go, there's your answers for this question here, question 19. Okay, all good. Now, let's move on to question 20. Two ships leave a harbour H at the same time. So we call H here, and we make this our harbour. And we're going to do like a north-south-east sort of line here, just to so everybody can get their bearings on what we're doing. Okay, so that's north, south, east, and west. Okay, just a quick line. One of them sails in the direction south 70 degrees east. Now, south 70 degrees east, I'm going to represent that using a red line. Okay, so south, and then you go up roughly 70 degrees east, like this. And it sails at 30 kilometers an hour. Now, I don't know how long to make this line. I'm just giving it a generic line. The other ship, Q, sails in a direction south 20 degrees west. So I'm going to make ship Q a different color. We'll go to this. South 20 degrees west. So here's south, there's roughly 20 degrees, okay? After 2 hours, the ships are 61 kilometers apart. Calculate the distance traveled by ship Q. Well, this is not so bad, and I'll tell you why. Because it has to be a 90-degree triangle. Because this one makes an angle of 20 degrees with the south. This one makes an angle of 70 degrees with the south. Combine both of these together, and you gotta know that it's 90 degrees. Okay, that's brilliant. Now, after 2 hours, this means that the faster ship sails 30 kilometers an hour. So distance equals speed multiplied by time. 30 kilometers an hour multiplied by 2, which is the red ship actually, because it's the faster one. 30 multiplied by 2 is 60 kilometers an hour. So that's 60 kilometers, because it's 30 kilometers an hour multiplied by 2, which is 60 kilometers. Okay. Next thing, we know that the distance between the two ships, which we'll denote using a black line, is 61 kilometers. So this is 61 kilometers right here. So what we can now try to find out is what is the green one. Okay, so this is Pythagoras' theorem. 61 squared equals 60 squared plus x squared. And then 61 squared equals 3,721 equals 3,600 plus x squared, which is, I don't know what that is, 3,721. Take away your 3,600 when you move over the left side is 121. square root that, and you get x equals 11 kilometers. So x traveled 11 kilometers while the others traveled 60 and there's 61 between them. Okay, that's 20 done. Let's have a look at 21. So once again, we're going to get another harbour, like so. I'm just going to draw my my norths, east, west, and south lines. Okay, just so I know where to put the stuff. So x traveled due north at 20 kilometers an hour, while y traveled in the direction. So x traveled due north. So I'm going to use a color green. That's x traveling due north is the green line. And then y travel in direction north 60 degrees east. I'm going to use a red line for this. So here's north, and then go 60 degrees downwards, 60 degrees east. Then y was directly east of x. So I need to keep going until they're both at the same height. Then I can link them together using a black line, like so. Now, we know that this is north 60 degrees east, so we know this is 60 degrees. Okay, and it's after 1 hour, so this means that once again distance equals speed multiplied by time. 20 kilometers an hour multiplied by 1 is 20 kilometers. We know that this one traveled 20 kilometers. Okay, find the distance traveled by y. The distance traveled by y is the red line. Okay, and what we'll call the red line is, we'll just call it, for argument's sake, we'll call it y. Okay, so we know the adjacent is 20, and we know the hypotenuse is y. So what we can use here is cos 60 degrees equals 20 kilometers divided by y, where y represents the distance traveled by y. Cross multiply up, y cos 60, y is division on the right, which makes a multiplication on the left, equals 20, and then y on its own is 20 divided by cos 60, and 20 divided by cos 60 is 40 kilometers. So y is 40 kilometers. Okay, so then now we figured out what y is. Now we need to find the distance between the ships. Ship y is currently located here, and ship x would be located here. What I'd like me to find is the black line here. I could do Pythagoras' theorem, or I could use sine, cos, or tan. I might use tan. We'll call this distance d. So I could use tan 60 equals d opposite over adjacent, d over 20. Somebody else could have used sine 60 equals d over 40. Somebody else could have used 40 squared equals d squared plus 20 squared. These are three ways of doing the same question. I'm going to do it the tan way, so I'm going to bring the 20 up. So I'm going to get d equals 20 tan 60. And when d equals 20 tan 60, d equals 20 tan 60, which is 20 root 3, or 34.64 kilometers between them. To the nearest kilometer, so 34.64 kilometers should be 35 kilometers between them. Okay, that's done. Now we're on to question 22. On leaving a port, a fishing boat sails in direction south 30 degrees east for 3 hours at 10 kilometers an hour. As shown, what distance has the boat sailed? 3 multiplied by 10 is 30 kilometers. 3 hours at 10 kilometers an hour. Okay, so here's the actual footage. Okay, so it goes south 30 degrees east, which is this, for 3 hours. So that gives me, that's 30 kilometers right here. So this green line here is 30 kilometers. The boat next sails in direction north 60 degrees east. So north 60 degrees east, which makes this one 60 degrees. Okay. Calculate how far the boat is from port B. So the end of the question wants me to calculate the yellow line. How far is the yellow line? Now there's a little trick here, guys. It's what's called a Z or an N. When two lines in a Z are parallel to each other, or two lines in an N are parallel to each other, these are known as alternate angles. What essentially it means is that this angle here is the same as this one here, or this angle here is the same size as this one here. I'm going to use the N, so what I can show is that this angle here, that's going to be 30. It's the same as this 30 here. Not talking about 30 kilometers, I'm talking about 30 degrees. And then these two angles combined are going to make it 90 degrees. Has to be a right angle triangle. Now, what do we know? We know the green line is 30, and we want to know the yellow line, because the fishing boat ends up over here. There's our fishing boat over here, and it's due east from port P. So how far away is it? Well, what we can use here, now let me see. Oh, we have another little trick here to play as well. If this is 30 degrees, this one here has to be 60, because they have to add up to 90 degrees. Okay, so I'm just going to blank out some of the numbers just to make this a bit easier. This 30 degrees we don't need right now. Okay, so that doesn't matter. We know that's 60. Okay, we know that this is a right angle because it's the 30 plus the 60. We know that distance is 30, which makes everything confusing. We're talking about 30 kilometers, not 30 degrees. So when we're looking at the 60, what we want to learn is the hypotenuse, which we'll call x. We know the adjacent, which is 30, so we're going to use cos. For part 2, we're going to use cos 60 degrees equals 30 divided by x. X is division on the right, which will make it multiplication when it moves to the left. And then we're going to, once again, then we're going to do 30 divided by cos 60. And 30 divided by cos 60 is 60 kilometers. So now we know that the hypotenuse is 60, which is brilliant. Now, write a note on the mathematical model used here. Do you think the length of the boat is important? Justify your answer. I suppose the length of the boat won't be important provided you use the same part on the boat. So as an example, if I got a rectangle to represent the boat, like this, let's hope I can group them together. You and you. Group. If I put the green point on here and this represents the boat, provided I take it on the same part of the boat, the measurements will be the same. So the answer is the length of the boat isn't important provided you take the measurements from the same point on the boat. Okay. Or the measurements of the boat will be so small in comparison to the overall distances that it won't make a difference. Whatever you want to choose. Now 23 for the win. Last one for me today. An aeroplane is flying from Clifton to Lisdoonvarna. To avoid flying over water, it must travel 150 kilometers in a direction south 42 degrees east. Okay. So it starts off at Clifton and it sails to, sorry, it flies to, sorry, it must travel 150 kilometers direction towards Galway. Oh, sorry, my fault. It's traveling towards Galway first. So the angle from here to here, I'm not talking about angle B, I'm talking about angle B plus this angle, this big angle here, that's got to be 42 degrees in total. Okay, so now that's 42 degrees in total starting off. Okay, that's the first thing I know. Okay, then when it gets to Galway, it turns 90 degrees. So this is 90 degrees here. And flies 80 kilometers to Lisdoonvarna, no bother. Explain why angle A is 48 degrees. Okay, well, what happens here is, guys, we're going to use alternate angles again. So remember the N I was talking about? So if this is 42, then this one's 42. So this one right here is 42. So, and then, so it's going to be 180, take away 90, take away 42, which is 48 degrees. Okay? So what you can say is that the angle between, so we use alternate angle, call it angle 1. Alternate angle 1 must be equal to 42 degrees. And then angle 1 plus 90 degrees plus angle A has to equal 180 degrees because it's a straight angle. So therefore, angle A must equal 48 degrees. All right, that was a tricky question. Write down the direction of Liston-Varna from Galway. Liston-Varna to Galway. Okay. So Galway would be, this is 42 degrees as well. If I'm starting with this red dot and I'm traveling from Galway to Liston-Varna, my fault. We know angle A is 48 degrees. So it's south 48 degrees west. South 48 degrees west. Okay, don't mind that little dot there. That doesn't matter. Next thing, how much further is it to fly via Galway than flying directly? Okay, well, if you add 50 and 80 together, it's 230 kilometers traveling through Galway. But if we use Pythagoras' theorem, because this is a right angle triangle, we should be able to find out the distance a direct flight will take. And the direct flight is basically this blue line here. Here to here is the direct flight, okay? So the blue line, which we'll call x squared equals 150 squared plus 80 squared. So 150 squared plus 80 squared is 28,900. Okay, square root that. I think it's about, I don't know, 170 kilometers. So 230 take away 170 is 60 kilometers more, because it's 230 take away 170. Calculate, find b to the nearest degree. Well, that's actually quite easy. I'll tell you why. Because if you look at this here, we found out earlier that this is 90. Okay. Oh, we can use tan inverse. If you look at angle B, lads, if you look at angle B, the opposite is 80 and the adjacent is 150. So tan B equals 80 divided by 150. Tan inverse 80 over 150. It should be a narrow enough angle now. And it's 28.07 to nearest degree. So 28. Calculate the direction from Liston-Varna to Clifton. Calculate the direction. Okay. Well, this should be, we're doing all right here, I believe. So get this one. If this is 28, this will make this angle here 90. It's going to be 180 degrees. Take away your 90 and take away your 28. Which is 62 degrees. That's 62 degrees right there. Okay. Now, I suppose this is a tricky one altogether. Lads, this is a really tricky one. Alright, fair play to you. This is a tough one, alright? So here's what I'm thinking. See the way we learned that A was 48? Yeah? Call this 90. And 48 and 48 plus 90 take away from 180. Because see this little triangle I made here? So it's going to be 180, take away 90, take away 48. Which is 42 degrees. And then to calculate this blue angle here, which I'm after, it's going to be 180, take away 42, take away 62, which is 76 degrees. Now, calculate the direction from Listavarna to Clifton. Well, I could say that it's east 76 degrees north, because you go east first and then 76 degrees north, or that's the same as north 90 take away 76 north 14 degrees east. They're the same direction as each other, right guys? And that's it, and we're done.